This is our introductory lesson on confidence intervals. The sampling distributions for the sample mean assumed we knew the population parameters. In real life or in reality, we do not know these parameters or else we would not need statistics. In reality, we cannot conduct a survey or a study for the whole population if our population is very large. It is very impractical, not economical, and would be very difficult to gather all data values from all the sample points of a population. That's why in this lesson, we will switch from fantasy land to real life. We know already what to do when the parameters are known. Now let's see how we can use that information when the population mean or the population standard deviation are unknown. At the end of this lesson, you should be able to first describe the role of statistical inference in estimation in terms of the population and sample. Second, explain the general form of a confidence interval and apply it to different statistics and conditions. Third, construct a confidence interval to estimate a population mean. And lastly, given a confidence interval, interpret the meaning in terms of the population. These are the key terms that you will be encountering in the lesson on confidence intervals. We have estimation, statistical tests, inferential statistics, point estimate, interval estimate, confidence level, the margin of error or error bound for a population mean, confidence intervals, the Z distribution, and T distribution. Now, what is a point estimate? Suppose you are trying to determine the mean rent of a two-bedroom apartment in your town. You might look in the classified section of the newspaper, write down the several rents listed, and compute for the average or the mean of the different rental fees. Now, this mean or the mean of the rental fees would be your point estimate of the true mean. The true mean that we are pertaining to would be the population mean. So our sample mean is a point estimate of the population mean. Another example for point estimate. If you worked in the marketing department of an entertainment company, you might be interested in the mean number of songs a consumer downloads a month from iTunes. If so, you could conduct a survey and calculate the sample mean and the sample standard deviation. Now you will use the sample mean to estimate the population mean, or your sample mean would be the point estimate for the population mean. And your sample standard deviation will be used as a point estimate for the population standard deviation. Now, we all know that we use sample data to make generalizations about an unknown population. That's why we are using estimates so that we can make an observation or an inference about the general population. So this part of statistics is called inferential statistics. The sample data will help us to make an estimate of a population parameter. Then we realize that the point estimate will be most likely not the exact value of the population parameter, but close to it, especially if your sample size is large enough. After calculating point estimates, we can construct interval estimates called confidence intervals. From the word interval, it means that there will be a range of values that will try to estimate the population mean. So a confidence interval is another type of estimate, but instead of being just one number, it is an interval of numbers. So the interval of numbers is a range of values calculated from a given set of sample data. And the confidence interval is likely to include an unknown population parameter. It's like saying that we are trying to estimate the population mean by providing a range of values. For example, we can say that on average, the mean performance of students in mathematics in a 100-item test would range from 70 to 80 points. The 70 to 80 is a confidence interval with a corresponding confidence level. Or how confident would we be that the true population mean would be inside our confidence interval. Now remember that a confidence interval is created for an unknown population parameter like the population mean. Now confidence intervals for some parameters have the form, we have the point estimate minus the margin of error, and we have the point estimate plus the margin error. So we have our lower limit, which is the point estimate minus the margin of error, and we have the point estimate plus the margin of error, which is our upper limit. For example, if you are saying 70 to 80, 70 would be your lower limit and 80 would be your upper limit. Now, what is this margin of error? So the margin of error depends on the confidence level or percentage of confidence and the standard error of the mean. You have heard already or you have studied already standard error of the mean in our lesson for sampling distribution of the sample means. Now, the margin of error is a term that you might have heard or read from a sample survey result. Example is a survey of the current approval rating of the president or the citizens' attitude on a particular new policy. In such surveys, you may hear reference to the 44% of those surveyed approved of the president's reaction. So this is a sample proportion. Now the survey had a 3.5% margin of error, or that is plus or minus 3.5%. So to get the lower limit, you are going to deduct 3.5% to the point estimate, which is 44%. And to get the upper limit, you will have to add 3.5% to the point estimate of our results. So this 3.5% here is called as the margin of error. So example, consider the distribution of serum cholesterol levels for all males in the US who are hypertensive and who smoke. Now this distribution has an unknown mean and a standard deviation of 46 milligram per 100 ml. Suppose we draw a random sample of 12 individuals from this population and find that the mean cholesterol level for this sample is 217 milligram for 100 ml. The problem states that we know the population standard deviation, we know the sample mean, but we don't know the population mean. Now, however, because of sampling variability, it is important to construct an interval estimate of the population mean or mu to account for the sampling variability. Because there are some changes when we take different samples at a time, then it is just right that we make an interval estimate for the population mean instead of using a point estimate, which is the sample mean. Now we can construct a 95% confidence interval for the population mean, which is 217 minus 1.96 times 46 all over the square root of 12. And then we have 217 plus 1.96 times 46 all over the square root of 12. Or that is 191 to 243. Now the question is, where do we get these values? We know what 217 is, we know what 46 is, we know what 12 is, But how about our 1.96? So this will be part of our next lesson.